Okay, hi everyone, this is another data analysis video, still focusing on visualizing data, exploring data through visualization. In this video I'm going to discuss box and whisker plots. So what I'll do is demonstrate how to create box plots so that we can see the scores on a variable, we can visualize the distribution of scores on a variable broken down by different groups, or separated based on some sort of categorical variable. And as I've done previously, I'm going to use matplotlib and also demonstrate how to do the same sort of thing using seaborn, which is often, I find, kind of easier, requires less code. Okay, so I'm going to run this first cell with importing the usual software libraries that I might need in this case. So I'm going to import pandas as PD, numpy as np, matplotlib.pyplot as plt, and seaborn as SNS. So usual nicknames for anyone who's seen the previous videos. Those are conventionally the sort of nicknames that people use. Okay, so I'm going to import some data, and it's data from like a graduate talk course, and it relates to assessment grades for students. So I'm just going to import part of the data, and I'm using the normal kind of pandas pd.read_csv file. So it's saved as a CSV on my computer, and this is the actual string name of the file that is saved as, this .csv file. I'm going to save it as a data frame object called dataframe1. You'll see the reason for that in a second, but I'm doing something slightly different to what I would usually do. I'm not going to import the whole of that data set, every variable. I'm just going to import specific variables. And now the way I've done that is I've created this separate object above called var_cols, so variable columns. I'm saying I'm just passing it a list of the ones that I want. So I want program grade and outcome. And then when I'm using the read CSV method, I'm adding this extra parameter, this extra argument, use cols equals, and I'm setting that equal to the name of this object, var_col. So if I run that and ask for the head of the data frame, what you can see here, we've got this nice pandas data frame. It's got the program, name of the program, or an abbreviation for it. So applied psychology, clinical health psych, PTI is a different program, a percentage grade on the assessment, and whether that was a pass or a fail. And I think there are about 63 participants, in this particular data frame. So if we look at this, I'm going to make use of program and grade essentially in demonstrating box plots. And you can see from looking at this, we've got 61 non-null entries in relation to grades. So there are 3 missing entries for grades. So we've got 3 missing scores essentially. You can see, if checking these, program is saved as an object, outcome saved as an object. That seems kind of suitable, bearing in mind their categories, and pandas as correctly imported, grade as a kind of floating point number as a decimal. But if I run this is na.sum, so I'm combining 2 methods here in one line. If I run that, you can see that it's summing up how many missing values there are. Is na would be is missing essentially, and you can see we've got 3 missing for grade. So what I'm going to do, the easiest thing for me to do, is kind of drop those 3 values so it doesn't affect our analysis. And to do that, I'm going to just create a new data frame object. I'll call it df2, and then I'm going to use this drop na method. So drop those 3 missing values. If we run the .info method on this new data frame object, you can see we've only got 61 data entries in this new df2 data frame object. Okay, so to create a box and whiskers plot, what I'm going to do is a little bit of extra wrangling. I'm going to create a series of new objects, one for each of the programs. So there are 5 programs altogether, and I'm basically going to create objects that cluster or group the grades for students on that program, okay, as a separate um, object or entity, essentially. So if we look at this, for applied site, I've given the object the name applied site for the applied site program, and I'm using the data frame 2 object using the loc method. And what I'm passing to the loc method is from the data frame 2 object, take the program variable, and if it is exactly equal to applied psych, work out the grade. So extract the grade and the applied psych students and just save them as this within this applied psych object. Same for the others as well. So cogneuro would be cognitive neuroscience, and basically just extracting the cognitive neuroscience students, the people whose program is exactly equal to that, and their grade, and saving that as a separate object. So let me run that, and it should give us 5 different. We're not going to use them all, but it's useful to plot them. So let's start then and create a really basic box and whiskers plot for 2 groups. So I'm just going to use the applied psych group and the cognitive neuro group. And to create a box plot using matplotlib, all we need to do is call matplotlib plt and the boxplot method. Oop, I've just messed up. My text there. I'll put that again. And if I run that, what we should get is a simple box plot that plots applied psych and cogneuro scores, essentially. So it's really simple in the sense that it's not labeled. We've not labeled which group it is. We've not labeled the axes. We've not given it a title. And I've also noticed it's printed all this kind of additional array information here because I've not used the plt.show command to sort of suppress this information. We'll do that next, whilst we have this really simple box plot, I'll just sort of mention some of the features of box plots while they're useful. So this yellow line in the middle that is kind of created as yellow as a default, that gives us the median for the data, and the box itself represents what we'd call the interquartile range. So the lower edge of the box represents the 25th percentile, the median obviously represents the 50th percentile, and the top of the box there represents the 75th percentile. The 2 whiskers, or these bars going off the top and the bottom, they are usually set to about 1.5 times this interquartile range. Okay, so you can still get data points that fall outside this kind of min and max for the whisker, but they would usually become considered kind of extreme scores or outliers. But that's really simple. It's a simple plot. Let's kind of build on it a little bit. So this time what I'm going to do is I actually want to label which group 1 is and which is group 2. So I'm creating this object called labels. I'm going to pass applied psych and a list to it of the two programs, the names of the 2 programs. I'm going to call the box plot again, but I'm adding this extra parameter. I'm saying we want some labels, and I'm set it equal to this labels object I've created here. Could have just put these in as a list here, but that's just an alternative way to do it. I'm going to suppress that, kind of use plt.show to suppress all that kind of information that it provides you above to make it look neater. So now you can see we've got each of the programs labeled, and we can see the kind of assessment scores for those 2 programs. So obviously here we're looking at a much wider range of scores in applied psych course compared to the cognitive neuroscience course. Okay, so we're building on that. Let's add some more stuff to it. Let's just add a title and a label for the y-axis. So to add the title, we're just going to use plt.title, and then we're going to pass it a string, whatever we want our title to be. I've called it program grade comparison, and then we'll add a label to the y-axis using plt.ylabel, and I've called that assessment score. So if we run that, we're just kind of building this up a little bit step by step. You can see we've now got a title. It says assessment score on the y-axis, and things starting to look a lot neater. Oh yeah, sorry, I've also added a third program there, PTI, and put a label on that. So you could do this. You could continue building this up. We could have all 5 if we wanted, but it just illustrates the point. You kind of just pass a list of the different objects you want based on the ones that I created up here, essentially. Right, so this is already looking a lot nicer. It's quite small though, so we can make the figure size larger by using this plt.figure fig size equals, and then in parentheses putting the kind of the width times height. So maybe for this, maybe we want to make it's on quite a scale from 0 to 100, the y-axis. So maybe we want the y-axis to be a little bit bigger. So we could, I've just specified 5 by 8, it's probably 5 inches by 8 inches or 5 centimeters by 8. But let me run that. The other thing you'll note that I've also done is I've kind of copied in here the syntax for how I created those objects, where I grouped each of the programs based on the grade as a separate object. The reason for that is I didn't need to do that in this particular cell because I've already created them. I could have just called them like they are here, but I kind of just wanted to illustrate you can do the whole thing rather than me having already created them here. I could have just done the whole thing in kind of one go by creating them at the same time as creating the plot. So let's do that. How's that look? And there, so there we can see, I think this is going to be 5 by 8 centimeters. You can see like the x-axis is much longer now. And let's just add a couple more style elements to make this look a bit nicer. So it looks pretty good at the moment, but it's quite basic, isn't it? It's quite plain, but there's nothing necessarily wrong with that. But we can make the lines bolder. We can add different colors and things like that. So all I'm going to do here is I'm going to use a for loop. I'm going to set the plot. Notice above, I didn't save the plot as an object. I just called plt.boxplot. But here I'm actually setting it equal to some object name. I'm calling it boxes, as in just some abbreviation for boxplots. And I'm going to, having saved it as an object, I'm then going to use this for loop to set some kind of style options. So for boxing boxes, I'm going to set the color, and I've passed it this hex color picker value, and I'm specifying a specific line width. So I'm using a for loop to set the edge color and line width. So the color that these edges of the boxes are going to be, how thick the line is going to be. Okay, and then I'm also passing a separate argument here, which is to set box.set, and I'm passing it face color, and again I'm passing it a hex color picker. What would we call this? It's a string, but it's a code basically, and it relates to a particular color. You can look them up online if you just search hex color picker. There's one extra thing. In order to get, if we just ran this as it is, we'd probably get an error, but I've had to add one extra parameter here, which I've not mentioned yet, which is this patch_artist equals true. So you have to set this patch artist equal to true, otherwise it won't for some reason recognize this face color parameter. So I've noticed there I've had to add that to the boxes object, and I'm using this for loop to basically set edge color, line width, and the face color. So what that's going to do is give the inside of the box a specific color. Okay, and the rest we've got the title Y label. So if I run that, you can see that looks quite nice. So the edge color is a nice blue color, the face color is grey, and our median line is still present there. It's also made that edge color, that edge a little bit thicker. So last thing to do is, it might be nice to kind of you might think, oh, well, it'd be good if we can make that median line a little bit thicker. And the way we can do that is using this median props argument here, and I've passed the dictionary. The dictionary basically specifies the line width and the size we want it to be. Okay, everything else is pretty much the same. So all I'm doing here is just kind of like a little bit at a time, building up and amending the plot. And as you can see there, it's kind of made this line much thicker, so it's a bit more visible. So there's lots of other options to style and customize these types of plots in matplotlib, and you could check out the online documentation to see what they are. One last thing I will do is just to kind of illustrate how the box plot works. If we use the .describe function, and I'm using it on the PTI program there. If I run that, you can see here it gives us the mean and standard deviation, but it gives us the percentiles, the minimum, the 25th percent, 50th, 75th, and the max. So we can see there 50th percentile 61. That's our median line, and if we look at the PTI box, you can see that's kind of at about 61. And the 25th and 50th are the top and bottom edges of the boxes. So sorry, 25th and 75th are the top and bottom edges of the boxes. So 31.75 here is the bottom of that box, which looks about correct, and 86.5 is the top edge. And then the min and the max in our kind of 5-number summary here, 0 and 98 would represent. So this one goes all the way from 0 up to a score of 98. There would be the top and bottom edges of the whiskers. Okay, so that is plotting in matplotlib. It requires a little bit of coding and creating objects so that they're suitably grouped. But we can also create box plots in seaborn. As I've said before, seaborn, it's kind of nice because it's convenient, and we can often do the same sort of thing. It's built on a matplotlib base, and we can often do the same sort of thing with much shorter or single lines of code. So to demonstrate box plots in seaborn, I'm going to import another data set, and this is a data set. It's a Titanic.csv. So this is actual data which you can find out. It's open source online, that relates to the passengers on the Titanic, what class they were, what fare they paid, how old they were, where they departed from. Let me run ahead and you can see some of that. Whether they survived, whether they were male or female, what cabin they were in, etc. Things like that. So quite interesting, quite a large data set as well. So if I run info on that data set, so I've saved it as an object called Titan, just an abbreviation for Titanic. You can see here it's imported the data and it's interpreted it. Generally, age as a floating point number as a decimal, sex as an object, male, female, things like that. Passenger class as an integer. So some of them are appropriate, some of them might need a little bit of amending. So if we look here at P class, it's imported it as an integer because these are numeric values, but these are codes, so 1, 2, and 3, first, second, and third, but they're really categorical values. And same with survived. This is a category, dead or alive, essentially, and it's saved them as integers 0 and 1. So they might, if we're going to do anything with them, we probably need to play around with them a little bit. Okay, but let's just create a simple box plot using seaborn. So we can use the sns.boxplot method. The data I'm going to use, I've specified the data, that's the Titan data object. On the x-axis, I'm going to plot passenger class. Remember, that's got 3 categories, first, second, and third class. And on the y-axis, I'm going to just plot the age of passengers. You can see there. So creates quite a nice, neat box plot with not a lot of coding required on our part. Okay, so let's look at something else. It'd be interesting to look at if we could look at whether were differences between groups of who survived, who didn't, and things like that. So what I'm doing here is we've got this survived variable, and as I said, this is a category base. It is shown, it's imported it as an integer, and it's got zeros and ones represent. So it's been dummy coded in some way. So what I'm going to do is I'm going to create a new categorical variable. I've just called it alive, which would be yes or no essentially. And I'm going to use the survived variable, and I'm going to use this the .map method. Okay, so 0 is dead, so I'm passing to the .map method a dictionary, 0 representing everyone who's dead, and 1 representing people who are alive. So key value pairs, 0 is dead, 1 is going to be alive essentially, and that's what those two values mean in that survived variable object. Okay, and I might have mentioned, I think a few times before, that when I try to map more meaningful category names or labels onto a categorical variable that's been dummy coded like that, what I like to do is leave the original variable alone and just create and append a new variable. So that's all I've done here. If we look at the head, I've created this new variable alive. It says whether someone's dead or alive essentially, and it's based on survived. So it should map exactly to 0 being dead, 1 being alive. Okay, so let's do something interesting now. Just to show you the different elements you can add to a box plot using seaborn. So we're going to use sns.boxplot again, the Titan data set. The grouping variable, the categories we're going to put on the x-axis is going to be passenger class again, so first, second, and third. We're going to pass the scale variable on the y-axis is going to be age, and we're going to specify hue equals alive. So that's going to tell us based on class and age, it's going to give us different colors for individuals who are alive or dead. So we're splitting by another categorical data variable. Okay, so you can see there first class, blue is dead, orange is alive, across all three classes. And the age, so it looks like kind of generally first class people who died were a little bit older. Okay, so let's look at another one. Let's have a look to see if there's a difference in who survived based on the fare they paid. So if I kind of run that, it creates this box plot. So not a great box plot, to be honest with you. It's all squashed at the bottom, and that's because seaborns had to pick the scale based on the data points, and we seem to have these one or two quite extreme scores here, like very high values. So someone was obviously very rich and paid a lot of money for their ticket, but it seems a lot more clustering of dead people who paid lower fares essentially than those who were alive. It seems like more people survived who'd paid higher fares, and we could do a similar thing to what we did above and sort of separate that out by sex as well. So same sort of thing, we're kind of seeing male female difference. It looks like, you know, there's maybe more females than males survived. That I think that generally is the case from the Titanic. More younger people and more females survived. I guess that was women and children first to lifeboats. But these are not great, are they, as box plots, because they just kind of all, because of the scale, they're all really bunched together. It's hard to see what's what. So we can change this figure size to make it bigger. And so what I've done here is I've added this extra argument here from matplotlib plt.figure, and then I've specified a figure size of 6 by 12, and then I've actually set the box plot equal to an object called AX. Yeah. And if we run that again, it'll give us the same thing, but it will have stretched out that y-axis a little bit, so it would be a little bit easier to see. the data. It looks a bit, you know, we could make that even bigger as well if we wanted to. If we wanted to sort of be able to much more easily see the differences that are present here. Lots of clustering at these low values, so it's hard to see. But it looks like the medium in terms of survival for males and females is about the same there in terms of the fair paid. Okay, so that's that is box plots. How to run them, how to create them in matplotlib, and how to get similar sorts of things. And just a demonstration of some of the ways you can split categories and then split them again based on the colour to get more detailed information.